From the Spec Network, this is Fragmented, an Android developer podcast where we talk about building good software and becoming better Android developers. I'm Donn Felker.
And I'm Kaushik Gopal.
Welcome to the show.
If you work on an Android app, and if you're listening to this podcast, I'm going to presume you do, you'll know that when your user reports a problem or a crash, it's the absolute worst feeling. To make matters worse, they might one-star your app, go on Twitter and complain about the app, and if they're feeling particularly merciless, probably go on Reddit or something and post it there. But you know what? They have absolutely every reason to. If you treat your customers basically as an off-site QA team, it's rude to them and it's just bad for business. As developers, we don't want to rely on customers to report errors. Instead, we want to catch this much early on. Ideally, you just have automated tests and these tell you when there's a problem. But, as we've talked about on the show multiple times, that's not always as easy as we want it to be. Because writing tests can be hard. That's why Sentry, our sponsor for today's show, tells you about errors in your code before your customers have a chance to encounter them. Not only do they tell you about the errors, they also give you helpful details that help you fix these errors. For example, how many users were impacted by this bug, the complete stack trace if it's a crash, the commit ID when this error was released, the engineer who wrote this line of code that was busted, that and a whole lot more. If your code is broken, let's fix it together. That's Sentry's tagline. I love it. You can check them out at sentry.io/for/Android. Sentry is a pretty common word. It's actually a pretty cool name for the service if you know the English meaning of the word. But I want to make sure you get that domain name right. It's sentry.io. Once again, sentry.io/for, as in FOR/Android. Check them out today and fix your errors before your users encounter them. Thanks for sponsoring today's show, Sentry.
On today's podcast, we're going to be talking about item number 20 in the Effective Java book. This is going to be the third edition. It's been a while since we've done one of these Effective Java episodes. We've had quite a few requests for people from various different listeners to bring these back. So I've decided to start bringing them back, but I'm going to change it up a little bit. Previously, we have started walking through all of these items basically in order. And we started off back when Effective Java was in the second edition. And we haven't got too far. We've, I'm stating item number 20. We've probably had close to that number of episodes on the Effective Java series. Now, however, the number of items in Effective Java is quite large. In fact, I believe it is somewhere right around 90. And the thing is there's a lot of things in Effective Java that are fantastic. There's other things in Effective Java, to be frankly and completely honest, that put me to sleep. This is a great book for learning about great practices in Java and everything around that area. You can learn a ton of information. And in that said, it's a very dense read. There's a ton of information. There's many times when I'll have to actually read this chapter 2 or 3 or 4, 5, 6 times before I can actually get in front of a mic and record it for everybody listening. And then there's other times that I might read it 4, 5, 6, 7 times and fall asleep almost every single time. So what I'm going to do going forward is I'm actually just going to pick and choose the ones that I find very interesting and the ones that probably have the largest breadth of implementation and basically the items that you're going to be able to get the most bang for buck out of inside of this book. Some of the items in here are just kind of good to know, and some of them are just fantastic. And so what I'm going to start doing is just grabbing off the gems, the low-hanging fruit from the tree, and I'm going to share these here. And so that's what we're going to be starting with today. I've kind of skipped ahead of a little bit here on the list. So if you were to look on the website at fragmentedpodcast.com, you would see under the menu, we have the Effective Java episodes. You'll see I've jumped ahead a little bit. I'm going to be covering item number 20 today, and that's titled Prefer Interfaces to Abstract Classes. So let's just hop right into it. Now, Java has two implementations to define a type that permits multiple different types of implementations. And you can do this with interfaces and abstract classes. Now, both of these mechanisms, as of Java 8, allow you to provide implementations for some of the instance methods. Now, the major difference is that to implement the type defined by an abstract class, a class must be a subclass of that abstract class. Now, here's the thing. Now, because Java only permits single inheritance, the restriction on an abstract class basically severely constrains our use to, type definitions, etc. So you can only really inherit from one abstract class. Now, however, this is kind of where the power of interfaces come in. Now, you can implement various different interfaces inside of a Java class, or on a Java class, should I say. And as Joshua Bloch, the author of Effective Java, says here, existing classes can easily be retrofitted to implement a new interface. Now, for those that aren't familiar, in Java 8 and of course in Kotlin, you can provide default methods for interfaces. So what a default method is let's say you've defined an interface and it has a method foo, and foo prints to, just uses system.println or whatever, and it prints out to the console. And you may just want to print foo everywhere. And if you implement this and you call foo, it just prints foo. Now, if you were to pre-Java 8, you were to create an interface, you would just create a void method, call it foo. You'd have to implement that method everywhere and probably replicate some of the logic if you wanted to just make sure that foo was logged. And in that case, you're probably thinking, well, I might as well put it in an abstract class and throw it somewhere up the hierarchy chain, which unfortunately then can cause rippling effects. And we'll get into that later. But as of Java 8 and Kotlin as well, you can implement default methods. So you can actually say, hey, this prints to directly to the output, which is really nice. So you can take that class that you have, your customer class, your product class or whatever, add your foo interface. And if it has a default method, you don't have to provide an implementation. There's a default there for you. Now you can override it to do whatever you would like to do. So your class will still adhere to the contract that's defined by the interface. A contract being this method is going to be available on this class, etc. But if you don't feel like implementing it, you don't have to. Now, back to the book here. Really what you really have to do is if you want to retrofit an existing class, all you really have to do is add any of the methods if they don't exist and add to your interfaces and so forth, and add an implements class, a clause to your class declaration. Now, he uses the example here of retrofitting classes with interfaces, comparable interface, the iterable interface, the auto-closable interface, where people will just slap these on there saying, hey, this is auto-closable, which means that it can kind of clean up after itself if it has some resources and so forth. And you're using try with resources in Java. Now, just as I said a second ago, inside of Java, existing classes cannot be retrofitted to extend a new abstract class. If you want to have two classes extend the same abstract class, then you have to place that higher up in the type hierarchy where it's an ancestor of both of those classes. Now, when you do this, and I'm sure you've ran into this before, this can ultimately cause a huge ripple effect through your type hierarchy, forcing all of your descendants and so forth to implement any of the new abstract class members, etc., whether or not it's appropriate. And usually this is where you find yourself thinking, maybe abstract classes and inheritance isn't the right decision here. So this kind of gets to the point where you start thinking about interfaces. And this is where, especially with Java 8, with default methods, interfaces become an ideal method for defining what are known as mixins. And loosely speaking, what a mixin is it's a type of class that can implement, in addition to its primary type, some optional behavior. So what that means is I could have a interface. Like I said, I could have my foo interface, and it may just print something to the foo line, and I just add that interface to 5 different classes. And I've kind of taken, I have a customer class, I have a product class, I have a, let's say a table class, right? And I have all of these built up, and I add the foo interface. I extend foo interface to all my classes. I've then basically mixed in that foo method into each one of those classes. So you think of it like a mixin, almost like you're mixing a cake. you're mixing in like an ingredient into that class, and it has everything there is an instance of foo, and it knows how to do something with foo. So I'm kind of mixing in additional stuff. Now, Joshua Bloch refers back to the comparable as a mixin interface that allows a class to declare its instances are effectively ordered with respect to the other comparable objects inside of that it may be compared with. So if you have a comparable thrown on a customer class, then what will happen is that customer class will know how to compare itself against other customer instances and sort itself, descending, etc. Now again, that's called a mixin because you're basically mixing in optional functionality into that type's primary functionality. And the reason why you can't do this with abstract classes is because a class cannot have more than one parent. So you can't really mix it in, but you can have multiple interfaces. Now, to dive deeper into interfaces, one of the interesting things is interfaces also allow for construction of non-hierarchical type frameworks. That's kind of a lot of words there. In fact, it's kind of confusing. What that means is and I really like this example that Joshua has, and if you don't have the book, I highly recommend you go pick it up. It's, again, Effective Java, the 3rd edition by Joshua Bloch. And again, to recover, interfaces allow for the construction of non-hierarchical type frameworks. What that means is, for example, let's say you had an interface that represented a singer, and then you had another one that represented a songwriter. And let's say we had the interface called singer, and that interface had one method called sing. You passed in a song as a parameter to that method sing, and it returned an audio clip. So the singer interface has a sing method that sings a song and it returns an audio clip that you can play. Now there's another interface called songwriter, and songwriter has a compose method that takes in a particular position of a song and then it returns a song back. So, all right, well, at this particular point in the chart, go ahead and compose this song, and that's the songwriter interface. So again, we have two interfaces, singer, which sings, and a songwriter, which composes. Now, here's the thing. In real life, we often have, in this scenario, a lot of singers who are also songwriters. So now because we use interfaces rather than abstract classes to define these types, it's totally possible for a single class to implement both that singer and that songwriter type, which is really nice. And here's a really cool thing that a lot of people don't think about a lot of the time is you can actually create another interface that extends both of them to make it a little bit easier. So you can actually create another interface, a public interface, singer-songwriter, and that extends the singer, songwriter interface. So you now have another interface that's called singer-songwriter that is a singer and is a songwriter. And then you can add some, methods to that, which may be strum a guitar and it would return an audio clip, or, sing in a different vocal intonation, and that would be a void, and you'd pass in whatever octave or something like that you want it to be. But now when you wanted to implement this interface, you could say, oh, this person is a singer-songwriter, and they're actually a singer and a songwriter. And it allows us to implement multiple different and construct different types together in a non-hierarchical way, because a singer isn't a songwriter, or songwriter isn't a singer. But in this instance, you can have one that is both. Now, you don't always need this type of and this deep level of flexibility, but when you do, the interfaces are like a huge, fantastic lifesaver. One of the good things also that interfaces allow you to do is enable like safe, powerful, like enhancements, functionality enhancements. And this is, basically via the wrapper class idiom. You've kind of created this wrapper almost. And what this basically allows you to do is you can basically provide an implementation assistance to the programmers in the form of a default method, which we talked about before. Now, of course, there are limits when you're providing this help to other programmers with an interface. There's limits on the default methods, that is. For example, you're not permitted to contain instance fields or non-public static methods, with the exception of private static methods. And you can't add default methods to an interface that you don't control. Now, here's the thing where things start getting kind of interesting in regards to interfaces. One of many things is you can combine the advantages of interfaces and abstract classes by providing an abstract skeletal implementation class to go with an interface. the first time I read this, I thought, this is a skeletal implementation. Like, what is Joshua talking about? This is really confusing. What is a skeletal implementation? Why would I have an interface and an abstract class? And then I kept reading it and rereading it, and it made sense to me. Now, what a skeletal implementation is an interface that defines a type, perhaps some default methods, etc. Now, a skeletal implementation that implements that interface and the remaining non-primitive interface methods, etc., things that aren't implemented, is going to be your skeletal implementation. That would be the abstract class. So you may have a interface that has a couple of methods on it, one or two. Let's say there's 5 methods, or 4. Let's go with 4. Two of those have default implementations. The other 2 kind of just really depend on how it's implemented. So you kind of have to just like leave those to be implemented by whoever's going to implement it. So whoever extends that interface will have to at least implement 2 methods, and then they can decide to override the other 2, which have default methods already for them. Now, what you can do is then you can create an abstract class that extends your interface. Your interface already has those 2 methods in it. So there's already the default implementation. You can provide a skeletal implementation of the other 2, saying, well, in this type of instance, I know that most likely you're going to want to follow this type of pattern. And you provide like a default implementation, and it may have, private members that you manage inside that abstract class. This is what's known as the template method. And so you're creating a skeleton that's an abstract class that people are going to implement. So at that point, they'll be implementing, whoever implements that abstract class will be implementing that interface, of course, because it's up the type hierarchy, but they'll also be implementing the abstract class. Now, by convention, skeletal implementation classes are called, and get this, here we go, abstract interfaces, or in quotes, abstract interface. That's like me with hand quotes. Think that abstract interface, where the word interface is the name of the interface that they implement. Now, a real world example, if you're completely confused, hang in there. A real world example of this is the collections framework, and that provides skeletal implementations that go along with each of the main collection interfaces. So you're probably thinking like, whoa, what are you talking about? We have a bunch of interfaces in the collections framework. We have the collection interface, we have the set interface, we have the list interface, and we have the map interface. We're all familiar with these. We've all used them, at least one of them. I know you have. You've seen them out there. What you may have seen out there a few times floating around when you're navigating to the source, trying to figure out some code, you may run across something known as an abstract collection, or an abstract set, or an abstract list, and even an abstract map. Now, these are skeletal implementations, and Joshua rightly says here, and this was like the aha moment where the light bulb went off for me. He says, end quote, arguably it would have made sense to call them skeletal collection, skeletal set, skeletal list, and skeletal map, but the abstract convention is now firmly established. So by default, we're just using the word abstract because it just has history, and that's just the way it's been, and that's the way it's going to be, so we've kind of just stuck with it. But this really made a lot of sense to me because I've always wondered, like, why is this called abstract collection? Like, what does it do? What's like, I don't know why it's called this. But if I would have read skeletal collection or skeletal list, immediately I think like, okay, that's the bare bones version. Like, oh, okay, that's a collection that does bare bones, a bare bone list, it's a bare bones set. It has the minimal implementation of what I need. Abstract list doesn't give me that. So this kind of goes back to a common thread that we have in software. Like, naming is hard. So always think about your names. So that's kind of a side tangent there. Now, if you're really interested and you want to see kind of what this looks like, just go inside of your IDE, IntelliJ, Android Studio, wherever you're working, go and look up the list interface and just go to the implementation of it. And you're going to see the methods that need to be implemented, etc. And then go to abstract list. And then you're going to see all of the implementation that's inside of there. And so it's actually pretty impressive to see all the power that's inside that skeletal implementation, which is really nice because all that stuff is inside of there for you. And if the skeletal implementation is built correctly, it can save a lot of time to all the implementers out there, and they can override the methods that they need to override and allow them to be much more productive. So if you are writing these, just know that, writing a skeletal implementation is going to be pretty simple because you're just going to extend your interface, implement the methods that you need. But however, it can be somewhat tedious. because you need to decide what methods and primitives and so forth that you're going to be implementing, how you're going to manage your state. So you kind of have to be careful of all those different types of things. And lastly, one of the most important things here is make sure you follow all the design and documentation guidelines that's also covered in item number 19 in Effective Java, which I don't believe we've covered yet, which is design and document for inheritance. But in essence, you want to make sure that good documentation is really put in place. It's absolutely essential inside of a skeletal implementation, either if it consists of default methods of the interface or separate abstract class, because you want to make sure that folks know what's going on inside of that skeletal class and why it's happening. Now, lastly, this is my own personal take on interfaces. I am a huge fan of interfaces. This is not inside of the Effective Java book. This is purely my opinion. I've been developing software for close to 18, 19 years now, and I have often found that when I use interfaces, it's much easier for me, and especially in statically typed languages such as Java, to test these things in isolation. So if I know that a particular type is going to be of that's another language. If it's going to be of an interface of type X, then I know that type is an X, and I can easily either provide a fake of it by just building it right there inside of my test and have it do exactly what I want. I can use a mocking framework to do what I would like. In short, it makes it much easier for me to test a certain piece of code in isolation, because if my code depends on a class that does X, Y, and Z, and that's perhaps an interface, instead of passing in a concrete implementation of that via a constructor argument, via a method argument, a setter, anything like that, I'll ask to pass in the interface, because then during testing, I can easily provide a fake, a mock, etc. And that's beyond the scope of this talk of what you should use, but it allows me to easily test and make me write tests. Essentially, if I'm definitely not using the Android framework, I can write JVM tests that are really fast. I can mock every single different type of interaction I could have. I could say, if this happens, throw an exception. If this happens, return an error, return an empty string. It makes it so easy to test all these variations of my class to make sure that everything is rock solid. So if you can, definitely try to use interfaces. So to quickly recap here, we have interfaces that are going to allow you to, multiple different types of things. So you can retrofit your existing classes by implementing different interfaces. You can provide default methods. Interfaces, again, are ideal for defining mixins. So again, a mixin is a type of class that implements something in addition to what it already does. So you could have a interface that does something special, and it can be implemented on 4 or 5 different things. And those 4 or 5 different things also do what they normally do, as well as what that interface implements. You again also can use interface as a nice wrapper using those skeletal implementation. And so again, some of the common skeletal implementations that you've seen out there are going to be things like the abstract collection, the abstract set, the abstract list, abstract map. If you want to kind of see how those things are done in frameworks that are used millions of times a second, probably based upon the popularity of Java, go take a look at the list interface and go look at the abstract list interface or collection, abstract collection. Just dive into them in your IDE and take a look. And then, of course, my own little added piece here at the end is interfaces allow you always to make testing a little bit easier. So we hope that helps, and we'll talk to you in the next episode. Don't forget, you can follow us on Twitter at FragmentedCast. If you'd like to follow me, Donn Felker, you can follow me at Donn Felker on Twitter and Instagram. And to follow my lovely co-host, Kaushik Gopal, you can follow him at Kaushik Gopal at Twitter and on Instagram. And lastly, don't forget, we also have a fragmented chat server. If you're looking for a place to interact with other Android developers, you want to chat, have a couple of questions, you need some technical help, or maybe even want someone to take a look at your resume, we have a hiring channel for that as well. Maybe you're even looking to hire some new team members. There's over 1,000 different members from all over the world inside of the Fragmented Discord chat server. Go to fragmentedpodcast.com, look on the menu. You can find the link for the chat server. You can sign up for free today. We'll see you there.
I want to thank Sentry for sponsoring today's show. Their tagline is, "Your code is broken, let's fix it together." They're a super cool crash reporting service that gives you all the helpful details that you need when detecting and fixing errors in your application. Don't wait for your users to report your errors and crashes. Use Sentry to catch them earlier. Check them out at sentry.io/for/Android. Once again, because Sentry is a common word, I want to make sure you get it right. Sentry.io. My thanks to Sentry for sponsoring today's show. That's it for the show, folks. Fragmented is hosted by Donn and me, Kaushik Gopal. We edit and produce all the episodes here on Fragmented. Sarah the Amazing Jackson from the Spec Network helps with production assistance and wraps our final mix. Our theme and ad music is by the national recording artist Blueprint from Weightless Recordings. You can find more Fragmented episodes at fragmentedpodcast.com. Thanks for listening, and we will catch you in the next episode.